Hello everyone, welcome to Coding Autos. So today we will see a code on linked list, which is insertion inside a single linked list. So before that, I'll explain you what basically is a linked list. So linked list is a collection of nodes, and each node will contain a data and pointer to its next node. So now the question is that how to implement this node. So as I told, that node contains a data and a pointer to next node. So we will implement a class called as node. We can take any name of the class, and then its data members will be one data which has to be inserted inside the node and the pointer to the next node. Yeah, and I have implemented this constructor. So whenever an object of this node is being called, so as you know that whenever the object is being called, the constructor is called automatically, but as it is a parameterized constructor, while making an object, we will pass the element which has to be inserted um, as a parameter, and then this constructor will be called, and that node will be initialized with the data which has to be inserted, and the next pointer will point to null. Okay, initially a node will be created whenever you want to insert an element. A node will be created, and inside that node the data will be inserted, and it that node will point to null. Okay, initially it will point to nothing, right? So this is all about our node class. Yeah, so now the question is how to insert an element inside the node. Okay, so for now we can insert an element at three places: at the beginning of the linked list, at the end of the linked list, and at any position of the linked list. So how to perform these insertions? So let's see it one by one. Okay, so initially, as there will be no elements, as there will be no elements at the start, so our head will point to null and our tail will point to null. We will take two pointers which we will use to um, navigate through our linked list. If we want to insert some element at the start, so to keep a track of where our start is, we will use head pointer, and to keep a track of where our linked list is ending, we will take a tail pointer which is initially pointing to null. Both are initially pointing to null. Head as well as tail is pointing to null initially. Okay, so as soon as I say that I want to insert an element at the start, I'll call this function which I have made. I'll show it to you. I'm passing the head, tail, and an element which I want to insert. So, okay. So insert at start, I'm passing head, tail, and data. So first of all, as I want to insert a data, I'll simply call the I'll simply make an object of node class. Okay, and I'm dynamically making this object, and as I'm dynamically making this object, it will return us the address where this node will be stored. So that address I'm storing it into the pointer ptr. It is a node pointer, as it is pointing to a as it is pointing to a node, so we have to make node pointer. Okay, so after doing this, we will get a node in which the data which we want to insert will be there, and its next will point to null. Okay, this one step is done. So now what we need to do? We need to insert that particular node at the start of the linked list. Okay, so as I've already told you that to know where our linked list is beginning, we are using head, and to know where our linked list is ending, we are using tail pointer. So I am passing head as well as I am passing tail. So initially this is the edge case which I am checking initially, that whether the head is null or not. If the head is null, which means that no elements are there inside the linked list. If no elements are there inside the linked list, then our head will be same as the pointer. That means the new node which I am making, this ptr pointer is storing the address of that node. Okay, so now the head will be pointing towards that same memory location. Okay, because no elements were there and this is the first element which I am inserting. So now the head will point to this node which I have currently made, as this is the first node, and tail will also point over there. Head and tail initially will point to the same element because only one element is there, so head and tail will be pointing to the same element. Okay, so this is the edge case which we have to take care of. And if some elements are there already inside the linked list and now we want to add some one element in front of the linked list, so this condition will work wherein the um, whichever node we have made now, whichever node we have to insert at the start, so we will the next, as I have told, that node have data and the next pointer, so the next pointer of that particular node will be head. So the next pointer of that node, yeah, so this statement, what this statement is saying, that the next pointer of that node will be pointing towards the head, which will be pointing towards our current head. Okay, so now this element has been added at the start. So as this element has been added at the start, so head has to be updated. So now head should be equal to ptr. Ptr is the address of the node which we have inserted, and head will always point towards the first element. Okay, so that is why I have written head is equal to start. So this is about the insertion at start code of linked list. Now let's see how to insert the element at the ending of the linked list. Initially same we will do. We will first make an object of that node class. After making an object, we have the node with the data as well as the next pointer pointing to null. Now I'll check whether the tail is equal to null or not. If the tail is equal to null, or even if we have checked head is equal to null, which means that there are no elements inside the linked list. So simply head and tail both will point towards the same node at which ptr was pointing. That is what I did here, same as earlier case which I've showed you. Or else if there are some elements inside the linked list, then what we can do, our tail is already at the last position of the linked list, so the next element of the tail, wherever the tail is pointing, so tail will have an element as well as the next pointer. So I'm pointing the um, last element towards ptr, towards the ptr, which is our new element to be inserted at the tail. So now uh, tail of next of tail will be pointing towards our new data, towards our new node. And as the new node which has been inserted at the tail, so tail has to be updated. So what will be tail? Tail will be now ptr, so address of ptr will be address of tail. So we have updated tail successfully over here. So this is about the insertion at tail. Now we will see how to insert an element at any position of the linked list. So I have passed a parameter as position, where at what position we need to insert the data which has to be inserted, and the head and tail. Okay, so initially if the position which we have to insert is 1, which means at the starting, so we will simply call insert at start. Okay, and after calling this, we have completed it, so we will simply return. No need to execute all of these. Okay, this is an edge case, so remember this. Or else if there are some elements inside the linked list already present, so I need to traverse the linked list until I reach the position, until I reach one position behind the position at where I have to insert the element. Okay, so for the traversal I am taking one more pointer called as temp, which is also a node pointer, and which will initially be at the same position where the head is. And now as I want to insert the new node at some particular position, so I'm creating that node and inserting some data inside the node, and initially it will point to null. After that, as I told that we need to count how many positions we are reaching. We have to reach exactly one position behind where we need to insert. Okay, so I'm initially count will be initialized to 1, and I'll go until the position minus 1. Okay, until count is less than position minus 1, this while loop will run, and I'll increment the count by 1. Okay, each time, and the temp will be always we will increment the temp each time. Okay, temp will point to temp of next if this condition is satisfied, and this loop will wait, and this loop will break only when we are if we want to insert at third position. So this loop will break at the second position, and it will come out of the second position. And now um let's leave this for a moment. Let's look into it. Now, as we are at the second position, as I told that if I want to insert element at the third position and I'm at the second position, so my PTR, what my PTR is, first what I will do, that the node which I have to insert, I'll point its next to the mm next of the temp. I mean to say that if I want to I want to insert the element at the position 3. Okay, and I'm at position 2 right now. Okay, so my temp is at position 2, so next of temp will be position 3. So what I'm doing is I'm pointing the node which I want to insert, I'm pointing the next of that node to the temps next, which means the element which is currently at the third position, I'm pointing my current node which has to be inserted to the third position, where to the node which is present at the third position. Okay, so so that those elements are not lost, we have to point it somewhere. If we would have done that, we are pointing the second element to the element which has to be inserted, then the rest of the elements in front of it would be lost. So what we are doing, that we are pointing the next of the element which has to be inserted with the third element, and then we have to point the second element to the element which has to be inserted. So you getting my point? So that is what I am doing here. Pointer next is equal to temp next. Then after I've inserted it, temp next is equal to PTR. Okay, what I have said, this is what I have said right now. Okay, now let's see condition where if the position is the last position which I have to insert. So how will we identify whether the position is last or not? Because we don't have any condition to identify whether that position is last or not. Okay, um, because we don't have the length of the linked list, right? If we would have the length of the linked list, we would have done something. We would have checked the length with the position, but now we don't have the length. So what we will do, we will check after coming out of the loop, we will check temp um, whether the temp is pointing towards the last position or not. If the temp of next is equal to null, which means that it is already at the last position, and we have to insert the element at the last position. So for inserting the element at last position, which means we have to insert the element at tail. So without worrying anything, as we have already written the code of it, we will simply call it and pass head, tail and data which is required by it. Head, tail and data is required by it. Okay, so we are simply passing it, and after we get the result, our work is done, we have inserted, so no need to go further, so we are simply returning it. Okay, I hope you understood this, what I have tried to say here. Okay, so once again, I'll explain this. Suppose, suppose there are five elements, five nodes inside your linked list, and you want to insert at the third position. Okay, so now you will run this while loop until you move towards your second position, because at the third position you have to insert the element. Okay, so you will move until you reach your second position. Once you reach your second position, you will stop over there. You will take the node which has to be inserted, and you will point the next pointer. It will have a next pointer, right? So you will point that next pointer towards third, towards the node present at the third index, third position, and then you will point the node which is present at the second index to the node which has to be inserted. Okay, so now the node which has to be inserted um, will be at the third position. So you have successfully inserted that element at the third position. Okay, so this is all about all the insertions which can happen in the single linked list. I hope I was able to explain you well about it. So now, as we have inserted all the elements at all the places inside the linked list, so let's see how to display it. So to display it, as head will be pointing towards start of the linked list, so I am passing the head, as it will be easy to traverse the whole linked list. So while our head is not equal to null, we will run this while loop. Okay, and we will keep on printing the data which is present inside the head. Okay, um, head will be pointing to a node. Okay, so we'll go inside the node and access its data. So this is what I'm doing here, data of head, and then I'm printing it. After printing it, I'm incrementing the head by 1. Okay, head will be pointing to head of next. So in this way we will be able to print all the elements inside the linked list, present inside the linked list. Now this is some data which I have taken. Insert at start 10, I'm inserting 10 at the beginning, then I'm inserting 50 at the tail. You can see this, right? So I'll simply run it and show it to you. See, at the starting I'm inserting 10, so 10 has been inserted at the start. I'm showing it to you over here. After that 50 has been inserted at the tail, so after 10 50 would have been added over here. Okay, after that I am inserting 20 at the start, so 20 at the start is added over here. 10 50 20. Okay, we are going good. Now 60 has been added to the tail. Okay, so 60 has been added to the tail. Now at position, no, sorry, at the start we need to add 30, so 30 has been added at the start. Everything is going fine. Now at the sixth position we are adding 232, so 1 2 3 4 5 6, sixth position we have added 232 successfully. Now the tail we are adding 4, so the tail also we have added 4 successfully. So we have done everything and our code is working fine. Now if you have any doubt in the comment section, you can definitely ask me. I would be very happy to help you. And also I would like to tell you that linked list is a dynamic data structure, right? It is stored inside, it is not stored in a contiguous memory location like array does. Yeah, we are creating a node inside heap, and we are simply connecting those nodes by the next pointer which is pointing to another node, so they are present anywhere inside the heap, and we are simply connecting them by pointing towards them. So this is about it. Here as you can see that I am not declaring any size of the array, sorry, size of the linked list, that how many elements I need to insert or something like that, as I used to do inside the array. So we can see that it is of dynamic nature. However, whatever elements we want we can simply insert it. There is no need to worry about. So that's it for today. I hope you understood the today's lecture. Feel free to ask me any doubts in comment section. That's it for today. Thanks for watching and bye bye.